Limit Laws, Part 7. Let's look at one more set of problems where we have to deal with indeterminate forms. Limits that cannot be determined by substitution alone, so we have to do some more work. We'll be looking at some limits that require factoring and multiplying by the conjugate. We need to evaluate the limit as x approaches 4 of 2 minus the square root of x all over x minus 4. So let's try direct substitution first. So we have 2 minus the square root of 4 over 4 minus 4. So that's 2 minus 2, which is 0, over 4 minus 4, which is also 0. So this is indeterminate, and we must do more work. When I look at this, I see this something minus something in my numerator, where one of those somethings has a square root, which means I probably want to multiply by the conjugate. I could try something else, but multiplying by the conjugate will probably be what works. So I have the limit as x approaches 4 of 2 minus the square root of x over x minus 4. And right now that is a 2 minus x, so its conjugate will be, instead of 2 minus the square root of x, 2 plus the square root of x. So we have 2 plus the square root of x over 2 plus the square root of x, because if I multiply the numerator by something, I'm definitely multiplying the denominator by the same thing. And now, every time you multiply by the conjugate, you're creating a difference of squares. So we will use that to help us simplify and expand the numerator. So we have the limit as x approaches 4 of 2 squared, which is 4, minus the square root of x squared, which is x, all over this x minus 4, times, don't forget, your 2 plus the square root of x in the denominator. When I look at this, I see this 4 minus x and this x minus 4, and they're very similar, but not quite the same. If we had a plus sign between this, so we had a 4 plus x over an x plus 4, then commutative property would say they're the same thing. But there's no commutative property of subtraction, so we need to try something else. Let's try factoring out a negative 1. So this is equal to the limit as x approaches 4 of negative 1 times negative 4 plus x, but negative 4 plus x is the same thing as x minus 4. And this will be over the quantity of x minus 4, oh, there we go, times 2 plus the square root of x. And now we have a common factor of x minus 4 in the numerator and denominator, so those will divide out. And we're left with the limit as x approaches 4 of negative 1 over 2 plus the square root of x. And now I can use direct substitution. So this will be equal to negative 4, sorry, I don't know why I wrote that, negative 1 over 2 plus the square root of 4. So that'll be negative 1 over 2 plus 2, which gives us negative 1/4. So the limit as x approaches 4 of 2 minus the square root of x over x minus 4 is negative 1/4. We need to evaluate the limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2. So let's try direct substitution first. So we have 2 squared minus 3 times 2 plus 2 all over 2 minus 2. So that gives us 4 minus 6 plus 2, which is 0, over 2 minus 2, which is also 0. So this is indeterminate. When something is indeterminate, that means we need to do more work. And since I see a polynomial over a polynomial, this is just a rational expression that I want to try to simplify. And I'll do that by factoring. So I have the limit as x approaches 2 of, well, x squared minus 3x plus 2 will factor to x minus 1 times x minus 2. And x minus 2 is already nice and factored. And now I can see that I have a common factor of x minus 2 in my numerator and denominator, so they will be dividing out, and I am left with a 1 in my denominator. So this is equal to the limit as x approaches 2 of x minus 1 over 1, which gives us just this x minus 1. Now I can use direct substitution, so I have 2 minus 1, which is equal to 1. So if you remember how to factor quickly, sometimes you'll have a limit that is quite quick to evaluate, even if it's indeterminate. So if you haven't already reviewed how to factor polynomials, especially quadratics, make sure you go back and review that. This is the last limit that we are going to try to evaluate for this section, and it is the most complicated limit that we have had to look at so far. So we have the limit as x approaches 2 of the square root of the entire quantity x squared plus 1 all over 3x plus 2. Oh man. Well, let's try direct substitution. So we have the square root of 2 squared plus 1 over 3 times 2 plus 2. And let's keep simplifying this. So this is equal to the square root of 2 squared, which is 4 plus 1, so 5, over 3 times 2 is 6, plus 2 is 8. Oh, okay. The limit is equal to the square root of 5/8. Always try direct substitution first, because if it does work, it's going to be so much quicker than the other methods. In the next section, we're going to look at something called the precise definition of the limit. So far, we've been relying on intuition, graphs, and algebra, but mathematicians really prefer to be more exact than that. The precise definition of a limit has some tricky notation here. So we have to deal with some compound inequalities that have absolute values. We have some epsilons and some deltas. So just be prepared for some weird looking notation, and try not to let the weird notation trip you up. It's not as bad as it might seem.